Hello. In this video, I'll go through the creation and use of curves, and it's the fourth tutorial in the series of geometry introduction, and it's also you will find curves as the fourth element in this geometry section. So we already discussed the points, the lines and polylines in previous videos, and this one is a natural extension to that material. Curves are more complex beasts than the polylines or points, in that they are represented by the Nurbs kernel of BitByBit, and they are also much more free form than what you would expect with polylines or lines. They deal with concepts of weights and knots and whatnot, so it's a bit less easy to understand how curves behave, but I'll try to explain that in this video. And you can also find a very basic example of the curve by opening this example of Nurbs curve along with points. You see that the curve was created here by following the path of points. And I'll start this video, as I start all the videos of geometry introduction, with just empty canvas. Nothing is in here. I'll just draw the grid now for myself to orient, and I do that to explain better how things get also programmed from the ground up. I think it's the material that is missing quite a bit in all of the tutorials, where I start with code reviews. I go through code that is already in there, and here I just code as I go along and talk and explain things, so it might give you also better understanding of the programming concepts behind BitByBit. So let's look into the curves. And as everything on the highest level of the curve, if you click that, you will see two components to drawing the single curve or multiple curves. You see that also when you click on the point, you will see that draw point and draw points. And also there are two subcategories in the curve for creating and applying various methods on the curve. And now in this case, the curves are also extendable. If you saw the polyline, the create category was not extendable because there's no standard shapes yet in BitByBit to create from polyline. We constructed the polyline also from the spiral of points because that's one of the easiest things to do. But the curve is a bit more complicated thing in the sense that the curves can be created in many ways, and they are a bit different than all the other concepts that we were dealing with. So Nurbs curves are usually created by having knots, control points, weights, and degrees, and you can of course read about Nurbs and how they behave, but usually these kinds of components are hard to use and hard to understand how they affect the curvatures of the geometry, and that's why we use mostly the curve through points component that will just force the curve to follow, to go through all the points that you have in the list. Or you can choose the Bezier curve. That's a better form of the curve, where you can also control the weights on every point. So the control points become a sort of attractors for the curve, and the bigger the weight you apply for every point, the more closer to that control point the curve will go. And we will be creating Bezier and both Bezier and this curve through points to just illustrate what I mean. And we also have here additional components for creating the circle, curve, and ellipses. So these are quite standard. You can drop them into the canvas, and you will see that you can just draw the standard curve immediately. Let's do that. You see that this is the ellipse arc with a center and an angle from 0 to 90, and if you go from 0 to 180, you will create the ellipsis that is a bit larger. And this is if you go, of course, to 360 degrees, you will end up with a full ellipsis that goes all the way, and that's how you can think about this concept of the curves. But if we want to create the curves that are irregular, we go about that by using those control point based approaches. So let's throw this one out and let's create the curve through points. And also, as we did with Polyline, I will first create a variable that will represent the list of points to go through. And I will create that, and I will set the list of points to be, let's find the list. This time I will use this component to assemble a list with multiple points, and I will use some more advanced bit-by-bit ways to create the items in the list. So we used some loop mechanisms in the previous video for making point, grid, and lines, but this time I'll just use this component to create a static list of points, because that's gonna be a bit simpler for me. And I will I will make just a list of 3 points like that, and I will also add a few extra points. So you see how you can increase, like, this is a sort of component that assembles entities into a list, and you have to then define each entity like I do now here. And if you need more entities, you can just click the settings button and drag and drop this item into the list to create the space for it, or room for it. And then you can just add your additional points into the list. So this list isn't interesting, of course. It's very basic. It has 5 points now, but they are all in the on the 0 space, so that means that they are all on the center. We can visualize them, so that will be a bit more helpful for us. So we can say we want to draw those points, and this is something that we use a lot in BitByBit. We want to edit something and we want to visualize immediately what the results are. So that way we can see what happens. And then I can also begin creating the curve through points, but I know for certain that curves don't like all points being on one coordinate, so I will for now disable this block so we don't have weird errors, and I will just visualize my list like that. And you see that there's 1 point here, and I will make it a bit bigger to be rendered better. And let's make the color orange. So now we can begin editing this list. So our first point will be on the 0, our second point will be on 2 and 3, and let's play now. So you see that now one of the points has moved its position. I think we can just continue like that to say that the next point will be on the 6, and let's move those components, and we see that this has been now created, but maybe it's better to say that it's on Z1. Yeah, not the best idea. Maybe Y is 1 and this is still 8 or something. Play. Okay, this looks a bit better. So this curve will try to follow this path, and let's continue to edit that like this. So it's 9. Maybe let's make it a bit higher so the curve will be a bit more interesting. And this last point will be 6. And well, let's return that back to 6. Yes, so now what I imagined to happen is that the curve should go through those points like this. What the exact result will be, we don't yet know, but we can try and enable this block and play the code. And you see that, as I've said, the kernel forced those curves to go through the points. So all the points are along the path, and that's the beauty of the Nurbs method that we've just created here and used. So I will not also go too deep into the degrees. There are multiple degrees possible in Nurbs for curves. The polylines are of a lower degree, the curves of higher degree. It mostly affects the curvature, basically. I don't know how best to explain that, so in the short video like this, so I'm not gonna begin doing that. But you can read about degrees in Nurbs. Standard is 3, and it's I think it's fine for us at this stage. What I want to also show you that, so this is now quite flat curve in essence, but we can of course play with this x coordinate in order to make it more interesting. So this will definitely do it. So you see now this curve became a bit more fluid and nice. So, and of course the curve still goes through those points. So this is one way of creating the curve, and it's quite a nice way of doing that. But I will do another method now, and I'll use the same points so you can see the difference better. But I'll construct the Bezier. I hope I pronounced that correct. It was a mathematician. I will create a different kind of curve. So I'll do now this Bezier curve. And I will use also the same points. But now I'll need another list, and not a list of points, but a list of weights. And to do that, I'll also create the, well, it's not actually necessary to put it into the variable, but we should practice that for ourselves. So list of weights. And I'll create the list of weights, and I'll set it to something similar like that. And each weight in this list will represent the weight for the point on exactly the same index as in the list of points. This is important to understand, but the weight is a bit simpler concept in that it's just a number. So the higher the weight, the more that point attracts the curve. And we can just try now with all weights being set to 0 to create this Bezier curve and see what happens. So it didn't like that, and probably because the weights are now set on 0. You see the error has been thrown, and it's maximum call stack exceeded. Nurbs kernel threw an error, and we should be careful about those. But now let's just change those to 1 and see if that helps. So it did help indeed, and you see that we've created the curve that has sort of similar trajectory, but now those points are not really on the path anymore, and the weight controls how much this curve goes towards that control point. So if we increase the weight on the second point, so I then expect this to go towards that point, and let's try and do 2. So you see this is a bit, this attractor now pushes the Bezier curve towards that point. And let's increase that even more. And now you see that it begins really stretching and forming a straight angle there. More of a sort of more of a sharp corner here. And I'm not exactly sure to what do I need to set it so that it sort of goes into full. Yeah, so okay, so putting it on 100 created the really sharp attractor, and it's more like a polyline then, sort of, but not, well, it's still a curve, but you have to realize that those weights are just way to inform the attraction force of the curve towards the control point. So we can do this, something like that, and then you'll see that we will get also very different results when we do that. So now it's created this approach, and it's nice to compare those two methods. They are quite different. Both can provide you with really good results depending on the situation, and I think, well, actually this this geometry is quite sculptural and interesting just to look at, but also the code is not too complicated to understand. So these are the ways to create the curves in BitByBit, but the Nurbs curves are really much more powerful than anything that we were talking so far, in that the apply category contains many things that you can do with those curves. So of course you can subdivide those curves into the equal number of segments. You can get points of those segments, and you can get the start points and end points, and you can do various things. You can measure the length of those curves. These are quite complex curves, so those kind of this kind of information can be really useful for you. You can also find closest points on the curve from other points, for example. You can, of course, get all kinds of information about the curve, like the degree and knots and weights and control points and many things that we will not be able to touch in the short introduction. I will be definitely making more videos about curves and how you can use those methods to make your life easier. But today we will just apply few of the things that we have here. And so let's try and do this one. Divide the curve to points by number of segments. So if we will use that, we will basically create a list of points, and to visualize those points we will just draw the point mesh. Of those points, and also few things to do here is that currently we just plugged our curves into the draw components, but what we want to do is plug it inside the variables so we could reuse them, and we could subdivide both of those components separately. So let's try and do that. Okay, so first of all we need the variable, and the variable is curve through points will be the first variable, and another variable will be Bezier curve. I'll create that. So now we have two variables to set. So Bezier is this one, and the curve through points is this one, and I'll do this, and I'll also do so curve through points goes here, and we visualize that, and Bezier curve will be this, and we will use the Bezier variable here like this, and we will now be able to subdivide Bezier first to the amount of segments that we want. So let's try and do that like this, and let's say we want to have 20 segments on that curve. Let's make the points a bit more distinct, and let's make their size 4 or 5 so we can see them better, and let's play this code. Okay, so point must contain. Okay, so I've made a mistake here. I've warned you guys to use the correct draw methods on the points and on the lines, and I did the mistake myself. I used this method instead of draw points method because the subdivision component of the curve created a list of points, so it created 20 points, and I had to use this list component. So let's configure this component again, and let's make their size to 5. And now you see that we subdivided the curve into multiple segments of equal length, and we have now 20 points on that Bezier curve, as you see here. So this is first code, and then we can also do the same on the curve through points. We can visualize that in different color. We can play this code, and you see that now I have also 20 subdivision points on the curve through points that are also of equal length each. So I think you begin understanding how the Nurbs curves are can be used, can be constructed, and also how the information of those curves can be used to be transformed into additional forms of data. And you see that we went from points to curves, then from curves back to points, and this kind of pathways can be used in many useful ways. So like now I could say that I may want to draw the lines between those points, for example. So just to illustrate that briefly, I can say I want to create lines with start points. I want to draw those lines in between. So I'm not gonna be drawing, and I'm not gonna waste time creating more variables here, because I can just do this, and I can do this, and now we can drop that away. And so if all is good, we see that we've created lines in between those two curves. So quite an interesting finale for this video, I hope. It looks quite an interesting shape, sort of a railway of two types of curves and the points in between those. The fact that amount of subdivisions is the same allows us to create those lines. So if I increase the number, you see that this the rail becomes more dense. So I will conclude this video on this note. I think it's good to understand the Nurbs curves, also mathematics behind it, but they are also useful without too much knowledge. So just be certain to go through those categories, understand how different things behave. So you can find all the methods that you can use on the curves here, and also if you expand, you can of course check what the radius of the circle is, what the radius of ellipse is, what is the axis, where is the center of the ellipses, and these kinds of things you can analyze by digging through this category. And I will be making more videos, as I've said, about the curves, so please subscribe on our YouTube channel and follow up for more, and of course ask questions in the comments if you need to. I will be there answering those. So thanks a lot, and I'll see you in later videos, hopefully. Bye.